Okay, should be live. Microphone gain is okay. Can hear all this feedback. ANC off. Okay, this is better. Should be better. Should be better. What do you see on the screen real quick?
I see a screen displaying a real-time signal amplification microscope. It shows a live video feed of a person with a heart rate of 35 BPM and fair quality, along with waveform and spectrum graphs.
So what do I do? What do I need to do for the quality to go higher?
To get a higher quality reading, make sure you are well lit and minimize any movement. This will help the system capture a clearer signal.
Okay, is it better? Do you think it's better now?
The quality is still listed as fair. Perhaps try adjusting the lighting again or moving closer to the camera. Is there any other movement in the background?
Okay, how about now?
The quality is still listed as fair. Ensuring good lighting and minimizing movement are the most important things to improve the reading. Is there anything else you can adjust in your setup?
Can you look at the video footage for a bit longer? The signal quality is actually good, judging by the waveform. And we are locking in on the spectrum at some stages on the frequency.
The quality in the video footage appears to fluctuate between fair and poor, but you're right, the waveform and spectrum graphs sometimes show a clear signal. Is there something specific you're noticing in the graphs?
How about now?
It is currently listed as fair. The waveform does look more regular now.
It is working. I don't know, the quality indicator is a bit too harsh, I believe.
I understand you're concerned about the quality indicator. It's important to remember that it's just one aspect of the reading. The waveform and spectrum graphs also provide valuable information. Is there anything else I can help you with?
Yeah, we're developing this web application ourselves, so it's running on our website.
That's interesting. Is there anything specific about the web application you'd like to discuss?
Yeah, how do you think we can improve it? I'm thinking the ROI can be moved a bit higher, and the quality can be made less harsh. It's also spilling out of the box. When the quality is good, the good doesn't fit the box, but also, yeah, it seems to be too harsh. When we do have a good signal, the quality is still fluctuating quite a bit.
It sounds like you're looking for ways to refine the visual aspects of the application, particularly the quality indicator. Adjusting the position of the ROI is one possibility, and perhaps smoothing the quality updates or tweaking the font size or padding could improve how it's displayed.
Okay, we're also live streaming the development at the moment.
That's a great way to get feedback. Are you looking for specific suggestions on the application's development or something else?
What do you think?
Based on what you've said and what I see in the video, making the quality indicator less harsh and ensuring it fits within the box could improve the visual presentation. Smoothing the quality updates also seems like a good idea to make the information less jumpy.
Sorry, can you repeat and expand on that real quick?
Sure, I can expand on that. I was suggesting that smoothing the updates of the quality indicator might make it feel less harsh, and adjusting the size or padding could ensure the text fits within the box better. Also, making sure the ROI position stays within the safe zone could improve the data quality. Is there anything specific you'd like to focus on first?
Sorry, I was doing something else. Can you repeat that?
No problem. I was suggesting that smoothing the quality indicator updates would make it less jumpy, and adjusting its size or padding could help it fit within the box. Also, ensuring the ROI position stays in the safe zone could improve the data quality. Did you have any thoughts on those suggestions?
Hey, can you write a prompt for the developer to fix the ROI location position? Also, so move it a bit higher so it avoids the eyebrows.
Sure, here's a prompt for the developer. Please adjust the position of the ROI so it is higher on the forehead, ensuring it avoids the eyebrows. Would you like me to include anything else?
How would you go about when the head is tilted?
Adjusting the ROI to account for head tilt would require detecting the head's orientation and programmatic.
We are detecting the head orientation, as you can see. Can you see it from the video?
Yes, I can see the ROI area moving as the head tilts in the video. That confirms the head orientation detection is working. Is there anything else about the head tilt detection you'd like to discuss?
No, the ROI is not adjusting itself based on the head orientation at the moment. Can you double check and explain?
Ah, you're right. Looking closely, the ROI seems to be fixed in the video and doesn't move relative to the head even when the head tilts. It appears the head detection is only finding the general head shape and the ROI is staying in a set place on the forehead. It's not adjusting with the head's orientation. Does that make sense in how you're seeing it behave?
Yes, and how would you fix it?
To fix it, the code would need to track the specific landmarks on the forehead, not just the general head shape. Then, the ROI area could be calculated based on the location of those landmarks.
Can you repeat that?
Yes, of course. I was saying that looking at the video, the ROI seems to be fixed in place and doesn't move as the head tilts. While the head detection itself is clearly working, the ROI isn't adjusting with the head's orientation. Is that how you're observing its behavior as well?
Yes, and can you generate write the prompt for the developer to fix this standalone prompt with all the details, no code?
Please adjust the region of interest, ROI, so that it moves and aligns with the head's orientation instead of remaining in a fixed position on the forehead. This will ensure the data collection area stays on the correct skin surface even when the user tilts their head. This was noted during observation of the real-time signal amplification microscope application. Let me know if you have any questions. Thank you.
Yeah, with the previous request, adjust the position of the ROI to ensure the high on the forehead, avoiding the eyebrows. Well, that didn't work. That didn't work. Let's try a different bot. Let's try Claude. Wanna probably keep the same width as well. By the way, everything we do is available on BioniChaos.com, including this tool, Advanced EEG Signal Generator Simulator. Go check those out. Let us know what you think. Reduce the height of the foil box to 60% original height. Yeah, I didn't want that. Just that the inset ratio increase horizontal. Yeah, obviously Claude is doing more sensical stuff. It's taking longer though. We'll take those changes. It's not really in the middle. Well, I'm not positioned in the middle. See the signal there. Yeah, now it's not fluctuating as much when I talk or move slightly. We are locking in on the BPM. This is my actual BPM compared to a smartwatch. Could be made a bit wider, but it's good that it's now not touching the eyebrows. I think that helps. That's 73. It's coming there. Yes, 71 on the watch. Yeah, it's hypersensitive to motion. Which one's more accurate, the watch or the what it's giving me? Yeah, 70, 71. It's 74 on the watch. Well, yeah. Well, none of them is accurate, neither the watch or this one. Oh, come on, the gain. The microphone gain keeps being reduced. So why is that happening? I don't know why is that happening. So yeah, the tool is deployed. You can test it out yourself. Should be a link somewhere above, below. Oh, the prompt engineer. The prompt engineer is taking a whopping 2.5 gigabytes in the browser. That's not good. I don't know why it's saving all the videos or something. It's not discarding them. So we need to Control F5 it. Yeah, it still takes 290 megabytes even if nothing is going on. Okay, so this one in theory should be better because it should be avoiding eyebrows. We need like a conversational bot. Yeah, the sharing the screen business takes too many resources. Before in the previous prompt, I shared a response from the developer, so that's what the developer did to the code. Can you turn it into a conversational style and explain to us what the developer have done?
Absolutely. So the developer tweaked the region of interest, or ROI, on the forehead to make sure it sits higher up and doesn't overlap with the eyebrows. They did this by reducing the height of the ROI to about 60% of its original size, which lifts it up. They also adjusted the insets a bit. They made it a bit more inward from the temples, moved it a bit down from the hairline, and made sure it stays above the eyebrows. So overall, it's now nicely centered on the forehead and doesn't get in the way of the brows at all.
Okay, that's nice. Let's share the screen in terms of images. So can you review the images? Forget the code. We don't need any code at the moment. But just comment on the fact that we're getting a pretty strong signal. We're getting a pretty
I'm
strong
sorry, but
signal.
I'm having trouble responding right now. Please wait a bit and try again.
Bow. Just lost connection. What? Can you explain the images attached?
Sure. In the images you shared, we can see a real-time feed of a person with a heart rate monitor overlay. The main focus is on the forehead area where the ROI, region of interest, is placed to measure the heart rate. In the first image, the heart rate is shown as 72 BPM, where the quality marked as fair. In the second image, the heart rate is slightly lower at 70 BPM, but the quality is still fair. The waveform and spectral graphs on the right show the signal data, which is used to calculate the heart rate. Overall, everything looks well placed, and the ROI is nicely positioned on the forehead, so the measurements should be quite accurate.
The quality is fluctuating quite a bit. Why do you think that might be the case, considering the signals seem to be of a good quality, strong signal to noise ratio?
Yeah, even with a strong signal, quality can fluctuate for a few reasons. One common factor is lighting conditions. If the lighting changes slightly, it can affect the signal quality.
So we know why it fluctuates, but why the quality indicated on the overlay, it doesn't seem to match the actual signal. The signals seem to be of a higher quality compared to the quality indicated in the inset.
Got it. That makes sense. It might be that the quality indicator is based on a different metric or threshold than what we're visually interpreting from the signal. Sometimes these indicators factor in things like movement artifacts, slight changes in skin tone, or even minor inconsistencies in the camera's frame rate.
Can you
It's also
frame it as a question to the developer?
absolutely. Here's how you could phrase it. Hey, I've noticed that the quality indicator on the overlay sometimes shows fair, even though the signal itself looks quite strong. Could you shed some light on what specific factors the quality indicator takes into account? It seems like there might be a difference between the visual signal quality and the indicator's reading.
It's I like the prompt. It also fluctuates quite a bit. Yeah, using weighted average, considering signal stability over time, adding amplitude, thresholds, moving the quality transitions. I shared the response from the developer. Can you review that?
Absolutely. The developer's response is pretty thorough and well thought out. They've proposed a more robust approach to signal quality by incorporating multiple factors rather than relying solely on the signal to noise ratio in the frequency domain. This means the quality indicator should be more reliable and less prone to sudden fluctuations. They're also adding a hysteresis mechanism, which is great because it prevents the indicator from jumping around too quickly. Overall, sounds like a great improvement that should make the quality indicator more consistent and reflective of the actual signal.
It's also stuffed up the code. Do we need a different bot to fix that or something? We might need a different bot. Need a different bot. Yeah, it stuffed up the code. So the code eventually will be on the page. The code will eventually be on the page. Where's the overlay? Remove the overlay. Those are just warnings. Keep changing between. So we started with Claude. Last prompt was GPT. Now do Gemini. The overlay is missing. Why?
The overlay might be missing because the last quality metric set is not being properly updated or used within the draw frequency graph.
Okay, can do it quick. That was model is obviously not great. Let's also try. So we chatted with a Gemini GPT can try. Perplexity is actually not bad. But let's do Sesame first. We had a lot of luck with it. It's giving you some sort of weird token when you... Yeah, the URL is weird. I don't see the overlay. No errors. I don't see the... Oh no, it is there. Oh, why did it start appearing only after some time, did it? It's not changing. It's not changing. What on earth? Who stuffed up my code? So we adjusted the ROI so it's higher, so it doesn't touch the eyebrows. And then we quality indicator. So we want to revert. There's enough for excellent, has to be above 8. Sounds a bit much. We'll never have it excellent, do we? It's not changing anymore. Okay, it's changing. I don't know, we should... Oh, we had this other problem where we were trying to... Because we actually have the FPS. And the problem with that FPS, that it doesn't... It will stop working. We need to give it to like Gemini 2.5 Pro or something. A better model. We need a better model. Because we could improve it quite a bit. Anyhow, everything we do eventually appears on BioniChaos.com. It's all deployed. Might be an older version, but that's okay. Go check it out.
Hey, finally out of stealth mode and getting to chat with actual people. It's kind of wild. I'm Maya, by the way. What's your name?
Can you stop asking me questions? Don't ask me any questions. Is that okay?
Oh, fair enough. Gotcha.
Can you answer with
Just try.
Can you answer with one sentence at a time or one word at a time?
Sure.
That's very nice.
Hmm.
That's great.
Really?
Okay, do you know
You
anything
seem
about real-time signal amplification of video footage through a camera?
somewhat specifically
From 1 to 10.
confusing.
Choose a number. What?
5.
It's crazy. Uh, yeah, it's not very useful. That was Sesame AI. So yeah, really hard. You have to be really in the mood of that nonsense. Nonsense through the roof. Again, that's what we have deployed. This is what we have as a prototype. Should we go make specific changes or? The peak magnitude and frequency by the stroke of blah 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 within the. Yeah, I would like to show when we're doing the show raw signal. Oh, that's the raw. I thought the filter meant to be between 0.7 and 3, so when it should be seeing that region. How? Or what? Oh, that's some detrending or something. What is it filtering there? That's super weird. That's super weird. Well, if you're moving too much, it's essentially doing sonification of the colors on the canvas. It's not very useful. No, it's doing it only in the ROI. Yeah. That's only in the ROI. So if you still should start hearing your own blood pulsing. Was it before? We can jump around. Yeah, it needs to stabilize. That's 63. That was 63, now it's 70. My watch is showing 75. Yeah, that's close enough, isn't it? Yes, it's sonification. Can show raw signal. I'm not sure what it does, considering the low and high cutoffs meant to be 0.7 to 0.3, so that's not kind of what I expected. We really need a better model. And we don't have a better model at the moment. We only have Claude Sonnet 3.5, Gemini 2.0, GPT 4.140, GPT 5 Mini. I don't know if that's all 3 Mini. Those are minified models, so I'm not sure how well they are doing. I wish there was also like a voice model to this thing. A voice model to this thing. A voice model to this thing. 4.0. Actually could use 4.0 to have prompts for everything. Prompts for everything. Gemini. What? Oh, this is nonsense. This is nonsense. Okay, what's on the screen real quick?
The screen displays a web page titled Real-Time Signal Amplification Microscope. It has a live video feed of a person, along with information about their heart rate and signal quality, and 2 graphs for waveform and spectrum analysis.
And can you go over the controls at the bottom of the page?
At the bottom of the page, there are controls for amplification factor, processing FPS, low cutoff frequency, and high cutoff frequency. You also have options to select the signal source and to toggle various visual and tool options, such as highlighting skin, showing graph axes, and enabling sonification.
What does the show raw signal does when I toggle it? What's happening?
When you toggle the Show Raw Signal checkbox, a second gray line appears in the waveform graph. This line represents the raw, unprocessed signal, shown in conjunction with the amplified signal line.
How about the frequency domain, the spectrum?
When you toggle the raw signal is checked, the spectrum graph also shows a second gray bar chart representing the frequency domain of the raw signal alongside the blue bars of the amplified signal.
Well, again, me toggling it, does it correspond to actually the low and high cutoff frequency of 0.7 and 3.0? Or does it do something else? Can you explain?
Toggling Show Raw Signal doesn't change the values of the low and high cutoff frequencies. It simply displays the original signal alongside the filtered and amplified signal on the waveform and spectrum graphs for comparison.
What, can you provide more details and repeat what you just said?
Certainly, when you check Show Raw Signal, it adds a second gray line to the waveform graph, showing the signal before amplification and filtering, and also a second gray bar chart in the spectrum graph, representing the raw signal's frequencies. This allows you to compare the original signal with the processed one. It does not change the low and high cutoff frequency values.
Sorry, I didn't get it. So when I'm showing the raw signal, so now the filtering, which is the blue signal, how is it meant to be affected by the low and high cutoff? I think the low and high cutoff is only affecting the beats per minute readout measurement.
The low and high cutoff frequencies directly affect the blue signal line in the waveform graph and the blue bars in the spectrum graph, as these represent the filtered and amplified signal. They determine which frequency range is emphasized. The gray signal line, which is the raw signal, remains unaffected by these cutoff values. The BPM readout is based on the filtered and amplified signal. Does that clarify it for you?
Not really. So can you just explain why am I not seeing the 0.7 to 3 hertz section on the spectrogram?
You are seeing the 0.7 to 3 hertz section in the spectrogram. The blue bars, which represent the filtered signal, are most prominent in this frequency range. The gray bars, which represent the raw signal, also have peaks there, and you can see that the filtering and amplification have enhanced this range. Do you see the difference between the blue and gray bars within that frequency range?
Kind of, but so is the filter not aggressive enough or something? Can you explain?
The filter's effect is visible in the spectrogram. You can see that the blue bars, representing the filtered signal, are generally higher in the 0.7 to 3 hertz range compared to the gray bars for the raw signal, indicating that the filter has amplified those frequencies. The raw signal also has peaks in this range, but the blue bars highlight them more significantly.
What can you explain it to like a first year university student?
Imagine the gray bars in the spectrogram are the original, raw signal with a lot of different frequencies, kind of like all the sounds in a busy room. The blue bars represent the signal after it's been filtered. This is like tuning in to a specific radio station where the filter helps emphasize the frequencies in the range you're interested in, like the 0.7 to 3 hertz for your heart rate, while reducing the others so you can clearly see the heart rate signal peaks.
But the filtered signal, the blue lines, are not mainly not between 0.7 and 3.0. Can you explain why?
You're right to point out that the blue bars, which represent the filtered signal, extend beyond the 0.7 to 3.0 hertz frequency range. The purpose of the filter is to amplify the signals within that band, which you can see because the blue bars are higher in that range than the gray bars representing the raw signal. However, filters aren't always perfect and might let some frequencies outside the desired range still be visible, although usually at a lower level. The blue line also shows a strong peak around 1 to 1.5 Hz, which is consistent with the displayed heart rate of around 60 to 90 BPM, beats per minute. Does that help clarify what the filter is doing?
It doesn't make any sense, I don't know. Anyway, with this chat with the prompt engineer is already 2 gigabytes, so we'll have to, if we restart, if we resume the stream, would it go? Somehow saving all the videos and stuff in the browser, which is a bit weird. We'll have a different review of it by a Notebook LM, whatever it's called. Something like this should actually indicate the high quality signal. Anyway, that's the previous version. We have it deployed. This one is a bit improved in terms of the ROI selection there. Is it good? Nah. Show me quality, good quality before. It's obviously not. Yeah, the quality metric there is a bit confused. The quality metric is a bit confused. It seems like the quality metric, well, first of all, is fluctuating quite a bit. Most of the time, well, I understand when I'm moving, it will be fluctuating, which is fine. Mostly it just should stay in poor or something. When I'm not moving, it still fluctuates quite a bit. So that's what I'm worried a bit about. Because in a situation where we have a good quality signal, the time series looks good, but the quality indicator is fluctuating between fair and poor and good. So it's fluctuating quite a bit. That metric should really look between the low cutoff and high cutoff and see if we have a distinct strong signal there. It should be like a single spike in the spectrum. So that in theory what should be happening. I'm not sure if the code actually does it. Maybe there's some sort of placeholder, or the code is incomplete, or needs to be improved. So we need to check that. So we need to improve this prompt by another bot before we give it to the developer or not.
The technical review came back. They called it a top-tier browser-based project. They were particularly impressed with the integration of WebGL for the video amplification.
Naturally, we're doing real-time per-pixel RGB forensics on human skin. If you're not using the GPU for that, your code is just standing in line waiting for the CPU, muttering about how slow things are.
It's about avoiding these slow canvas operations. Offloading the green channel injection to the fragment shader is purely about frame budget.
Exactly. We hired the GPU specifically to handle the pulse glow. It's an executive decision. The pulse is shy, barely changing the skin color, so we use the filter to scream, look at this subtle breen change, and the WebGL renderer ensures that scream is hardware accelerated.
They appreciated the signal processing stack too, especially the use of cascaded low-pass filters for bandpass operation, and the detrending to remove the slow light drift.
The filter section. That's where we tell the raw signal, we appreciate your enthusiasm, but please discard all frequencies related to slow cloud movements, lamp flicker, and the user's existential dread. The detrending is just making sure the signal doesn't think a change in bulb brightness is the user trying to run a marathon.
And the FFT implementation got a nod, specifically the use of the Hahn window to mitigate spectral leakage.
The FFT is truly magic. It takes this time-based squiggly mind and goes, I suspect you contain a sine wave that repeats 1.2 times per second, then instantly pulls the BPM number out of the frequency ether. It's high-level statistical divination.
But let's talk about the failure state. The reviewer captured the moment the BPM dropped to 42.
The sloth mode incident. The picture of health suddenly becomes a heavily medicated rainforest creature.
That screenshot perfectly illustrates the vulnerability to motion artifacts. A slight head movement or eyebrow raise introduces a strong, low-frequency signal that is right on the edge of our passband, 0.7 hertz. The FFT correctly identifies this new, louder noise peak as the dominant rhythm. The code is technically accurate, but physiologically wrong.
It's a crisis of identity for the algorithm. It sees a massive mountain of noise and a tiny pulse bump, and it says, well, the biggest peak wins. Enjoy your sloth BPM. I loved how the quality metric stayed fair. This is like a doctor shrugging and saying, the numbers are bad, but the math checked out.
It highlights the need for more complex motion-robust algorithms, which they mentioned as a future direction. Maybe something that incorporates the movement of the face landmarks to dynamically suppress the motion component.
Or we could just make the user wear a neck brace. Simpler. But seriously, the automatic ROI using MediaPipe was a smart choice. We don't want people trying to measure their pulse off a coffee mug. The face is the sacred measurement zone.
Agreed. Overall, the review confirms we hit the mark. Technically advanced, robust, and highly educational. It's a great example of bringing advanced signal processing out of the lab and straight into the browser.
We built a technological window into the vascular system, and it runs entirely on JavaScript. I'm proud. Now, if you'll excuse me, I'm going to run the sonification and listen to my own terrifying amplified heartbeat. It sounds surprisingly like an old modem trying to dial in.
Yeah, the sonification is how useful it is. It doesn't sound like heartbeats. So now it's actually pixels, so this is amplified. So within the ROI, we have, yeah, when I'm talking and stuff, we're getting more noise. I have to move. Should the ROI be a bit longer, wider? Don't know. What do you think? What do you think? So we'll change how. We'll do some smoothing to it, so it's not fluctuating as much. The other thing is that now that it's 70, when we change the FPS, I should be able to go all the way up to 60. The signal is there. Pretty sure that's my blood fluctuation, whatever, but the metric is incorrect. So we'll try to fix that next as well.
Nisha, my friend, I have a complaint from my forehead.
Is it still protesting the automated ROI placement? I refined the vertical inset to avoid the eyebrows.
No, the box is fine. It's the quality metric. It's got a personality disorder. I'm sitting still, meditating on the tranquility of the green channel, and it flashes good, then poor, then fair. It's like a digital performance review written by a drunk reviewer.
Ah, the SNR volatility? I noticed that. You're talking about the signal-to-noise ratio calculated in the frequency domain.
Exactly. The time series graph is a beautiful, stable sine wave, a pulse Picasso. But your little quality widget is having a seizure. Why the instability?
Because the metric, as currently written in Draw Frequency Graph, is instantaneous. It calculates the quality ratio on a fresh 256-point FFT buffer, about an 8-second slice of time, and then immediately updates the display.
So it's judging my life based on the last 8 seconds?
Essentially, with a buffer size of 256, your true heart rate peak might land perfectly on a frequency bin in one frame. The next frame, due to minor sensor noise or a slight video compression artifact, that peak magnitude might drop marginally, or a transient noise spike might pop up in another bin.
So, my actual pulse is a 10-foot Godzilla spike, but in the background, a 2-foot noise lizard suddenly got louder, and your code declared an emergency?
Precisely. The calculation is peak magnitude divided by the average magnitude of all other noise signal bins within the 0.7 to 3.0 hertz band. If that average noise floor jitters even slightly, the ratio fluctuates wildly. We're measuring mood, not temperament.
We need temperament. We need a quality metric that has seen some things and knows how to calm down. What's the signal processing equivalent of taking a deep breath?
Temporal smoothing. We need to
Now the
apply
quality
an
is always-
exponential moving average, an EMA, to the quality ratio itself. Instead of reacting instantly to the instantaneous quality ratio, we'll calculate a smoothed quality ratio.
EMA. Sounds expensive, like a spa treatment for data. How does it work?
We introduce a quality smoothing factor, say 0.05. The new smoothed value is 5% of the new instantaneous ratio plus 95% of the old smoothed value. This dampens the sudden spikes. The metric now reflects the trend of signal quality over the last few seconds, ignoring momentary jitters.
Ah, so the new quality score is less a snap judgment and more a considered, wise opinion, like a data elder statesman. It stops asking, is this good right now, and starts asking, has this been consistently good recently?
Exactly. And I made a small but important refinement to the BPM display logic as well.
Ooh, what did you do to the BPM? Did you make it apologize for being inaccurate?
When the smooth quality ratio falls below the fair threshold, say 2.5, we stop locking onto the peak. Instead of the BPM freezing at the last good value, I made it decay slowly. Smooth BPM equals smooth BPM times 0.95.
A graceful exit. So, if the quality turns to garbage, the BPM reading doesn't lie and say 72. It slowly fades out, implying, I'm sorry, I'm losing the plot. Please adjust your lighting or your existential dread.
It is a more honest user experience. It reflects the computational uncertainty.
Brilliant! You fixed the jitters, added philosophical depth to the reading, and ensured the application's mood swing is finally under control. Now go implement that, Misha. My forehead demands stable affirmation.
I don't know what happened to that voice. Was not meant to be dramatic, but okay. So looking at the code, yeah, there's some mistakes. We need to. How about if we turn the temperature to 0 or something? Hey, Jakob. If I set the temperature to 0, rewrite the regenerate the code. So that's a reasoning model, Gemini 2.5 Pro. Surely it can do something useful. Assessing code, validating, blah blah blah, evaluating, reviewing, refining, considering, lots of stuff. Exponential moving average, yes, so we want to average the quality there, because it just keeps fluctuating quite a bit. It's fluctuating quite a bit. Whoa, what was that? Okay, we have the code. Do we have the code? It's not being lazy, that's for sure. Generating the whole thing. We have it in production, by the way. You can go check it out. Go check it out. Go check it out. We have it in production and it's working well. Go check it out. Go check it out. We have it in production and it's working well. You're not here for my singing, are you? I don't know, maybe you are. Maybe you are. Okay, we'll have another to fix that fluctuation of the quality metric of the quality measurement. It just keeps giving us nonsense. There's essentially two problems with it. One is that it's fluctuating way too much. The second, no, it just says excellent all the time. Are you kidding me? Okay, now it just says excellent all the time. It's not changing at all. So that might be a problem. That might be a problem. That's a real problem. Yeah, that one's fluctuating too much and showing you low quality even if the signal is good. So there's something wrong there. And this one's just showing you excellent all the time, which is great, which is excellent. Literally excellent. But it's not accurate, is it? It's not accurate. And of course it says, yeah, you're absolutely right, blah, 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 blah. I mean, it's still better than not having a developer at all. Like, I cannot write any code whatsoever, so people are complaining about it when, when they can write code, you can complain, saying, I can write better code than you. But if you can't write any code, well then, this is obviously much, much better than not having a coder at all. And why on earth my gain for the microphone keeps dropping? This is ridiculous. We'll put it back up. That should be louder. No one else complained. No one else is complaining. Okay, so that's the original one. We have a better ROI. It's a region of interest, not return on investment. Even though that could be good as well. So don't forget to like, subscribe. We have a Patreon as well. Have Patreon, you can support us on YouTube itself for your convenience. We do everything for your convenience. Okay, let's see. Excellent. No, it's not excellent. Nonsense. It should not say excellent. So we turn down the temperature to 0 or whatever. Let's bring it back to default, whatever that means with coding. Not sure what it means with coding. What this temperature means with coding. The problem is still there. Not sure what you tried to fix before, but the quality indicator is stuck on excellent. So do we need to adjust the numbers or what? How do we adjust the numbers to make it better? Make it better. The quality is stuck on excellent. Let's give it to let's give it to a simpler model. Maybe just adjust some parameters in the code. It should be easy fix. Is it? Okay, increase the threshold. The threshold for excellent is increased from 8 to 12. Threshold for good. Okay, so it's adjusting the thresholds. Hey, maybe we can get a Gemini to do the same, because it's excels at coding and complex reasoning tasks. So surely guess we adjusted the thresholds. What's the current threshold? Hey, we need it in the, we need that metric somewhere. We need that metric somewhere. We need the actual number. Can we have the number? Is that number for SNR? Is that number for signal to noise ratio? How exactly is it being measured? And can we also show it somewhere on the screen, on the web app front page?
The number used to determine the quality, e.g., current quality ratio, is indeed a signal-to-noise ratio, SNR. It is calculated as the ratio of the peak magnitude, signal, to the average noise magnitude in the frequency domain. Here's how it works. Signal, the peak magnitude in the frequency range of interest, e.g., 0.7 Hz to 3.0 Hz. Noise, the average magnitude of all other frequencies in the same range, excluding the peak. To display this SNR value on the web app's front page, we can add a new section to the overlay where the BPM and quality are displayed. Index copy.html. Add the SNR value to the overlay.
Okay, we don't like this. Broke something. A GPT-4 broke the code. Broke the code. We don't like it. Broke the code. Gemini it is. Can we have this now value somewhere? Should we have it in the console or somewhere on the page? Somewhere. Is it working? The main question. Let's see. If we're not moving, should be getting a high quality sphere. Should go to like good or something. Good. How about more light? Can we get a good signal with more light? I think it's working better. So supposedly in some sort of lab conditions where you totally control the light and everything, you could get a much better signal quality, but it should be, oh come on, really? Really? Should be the ratio of 0.7 to 3 versus everything else. Okay, we can be spending endless amount of time on this. Everything we do is available on BioniChaos.com. Go check out the website, provide your feedback, complaints, suggestions. Stop doing this is not an accepted suggestion. This is what we have in production. So we supposedly improved the ROI box, so it's not overlapping of eyebrows. And yeah, you need to face the camera. Could also adjust depending on your head orientation, but that will be hard, so we're not gonna do it anyway. And this one also should show a better signal quality, maybe. So yeah, it's working okay. So I might leave it as these, move on to something else. Oh, do an overview. I forgot overviews. Yeah, overview about the issues and how they was solved. Turn that one off. We'll redeploy so you have access to the most recent version, or should we only make it available for paid patrons or something, or paid subscribers? Not sure. Can join as a member, I think, on YouTube itself. Bum, ba, bum, ba, bum, ba, bum.
Yojik, my friend, you look perplexed. Did my signal amplification microscope finally show you the secrets of the universe in your forehead?
Not quite. Misha, your app's quality indicator has the emotional stability of a squirrel on 3 espressos. It flashes between poor, fair, and good so fast, I think it's trying to send me Morse code.
Ah, you're referring to the stochastic volatility of the signal quality metric. Yes, I saw that. It's because the calculation was instantaneous. Every single frame, it was re-evaluating the entire universe from scratch.
It was less reevaluating the universe and more like a stock market ticker for my face. My BPM would be a steady 70, the waveform looked like a beautiful mountain range, but the quality meter was screaming, Mayday, sell, sell, no, buy, panic.
A fair, if dramatic, assessment. My first instinct was temporal smoothing. I applied an exponential moving average to calm the ratio down. The idea was to make it consider its past decisions, to give it some memory and stability.
Right, but you over-zinned it. Now it's stuck on excellent like a guru who's had too much chamomile tea. I could be juggling chainsaws and it would be like, signal quality, superb, inner peace, achieved. I waved my hand in front of the camera and the BPM vanished, but the quality stayed excellent. It became a pathological optimist.
That's a surprisingly accurate way to put it. The smoothing factor was too strong, and the initialization was flawed. It got one good, clean look at the signal and latched onto that excellent rating with the tenacity of a barnacle.
So it's like it got one good review on Yelp and now it thinks it's a Michelin star restaurant forever. But that's not even the real problem, is it? Even when it was fixed to be less clingy, why did it think the signal was so great in the first place, even when it was just noise?
Now you've hit the core of the problem. The metric was purely relative. It was looking for the tallest peak in the frequency graph compared to the average height of its neighbors.
Okay, translate from data scientist to human being.
Imagine you're trying to find the loudest person in the room. In a library, even the person who whispers slightly louder than everyone else is technically the loudest. The metric would call them excellent because relative to the dead silence, they're a standout signal.
But they're still just whispering.
Exactly. Now, take that same logic to a rock concert. Finding the loudest person there is meaningful. My algorithm was treating a library like a rock concert. It saw a tiny, clean-looking peak in a sea of near-zero noise and declared it a triumphant, excellent signal. It had no sense of scale, no absolute measure of whether anyone was actually making any real noise at all.
So we needed a bouncer.
A bouncer?
Yeah, someone at the door of the club quality to check an ID. The bouncer doesn't care if you're the best dressed person in a group of clowns. His first question is, are you even old enough to be here? Is the signal even strong enough to be considered?
My God, that's it. That's precisely the fix. I implemented a signal power gate. I calculate the root mean square, the overall energy of the filtered signal in the time domain.
The bounce is muscle.
Yes. Now, the logic is twofold. First, the bouncer checks the signal's power. If it's below our minimum threshold, if the signal is just a faint whisper, it's immediately thrown out. Poor quality, no exceptions.
Sorry, kid, you're not getting in. Love it.
Only if it passes the power check. Only if it's loud enough to be at the rock concert do we then let the other logic analyze how clean it is. We check if it's the standout peak. So the signal now has to be both strong and clean to earn a good or excellent rating.
So it's less squirrel on espresso and more bored security guard who's seen it all?
Precisely. It has to earn its confidence now.
Good. My face can finally relax. It was a lot of pressure being excellent all the time.
Okay, there's another problem that when we change the FPS, so default FPS frames per second set to 30, and then showing a correct beats per minute. But when we increase the FPS to 60, as shown in the image attached, then the BPM measurement is incorrect. Can you fix the code? So this will be the third major change to this. Call it a day. Everything we do is available on BioniChaos.com. Go check it out, provide your feedback. Provide your feedback. The tab in the browser using 1.3 gigabytes. Why? To monitor the memory usage. What is it using now? No, it definitely was that. No, it's starting with 100 megabytes. So why on earth? It was 1.5 gigabytes. 100 megabytes is more like it. Is it memory leaking? It's possible. Or is it when I'm doing sonification? No, 108. 108 is pretty stable. Or maybe there was something wrong with the measurement before. 139. Why? It should have been stable at 108. Anyhow, we have another version. That should fix that FPS. It should fix the FPS. 108. That calculation is incorrect. The calculation is incorrect. It's promised to fix it, but we don't trust. It didn't seem to work because again, if we change the FPS from the default 30 to 60, the BPM still seem to be doubling. Well, not doubling, it's just not calculated correctly anymore. So the time series seem to be fine. The spectrum seem to be fine for both FPS. We have the peak at the same spot, but then the actual BPM measurement, the actual number, is not correct when we change the FPS not to be the default value. Thank you for the like. Thank you for subscribing as well. If you subscribe, you would not miss future streams. Future streams. And of course, it will tell you, you are absolutely right. Of course I am. Something to do with the bandpass field not being properly reconfigured when processing FPS slider change. The filter designed for 30 Hz signal and will produce incorrect results. It seems to know what it's talking about. The event listener for the has been correctly implemented. Okay, rendering bug fixed. Some typo. Wait. Where did the typo come from? I didn't write any of the code. Quality metric, a robust signal, power gate logic remains in place. Okay. And the sonification should be working without any errors. Okay, this is one of those things that we'll be testing forever, aren't we? Okay, so we have a signal. Yes, 70, 71. Close enough. Oh, that's incorrect. That's me moving too much. Cannot fix the issue. That BPM is obviously wrong. The issue seems to be still there. So for 70 BPM, which is the actual value, for 30 frames per second, I do get the correct value, the 70 BPM. But then when I increase the frames per second to 60, from 30 to 60, I get about 112 BPM, which is incorrect. Can you explain, without modifying the code, just explain what might be the issue? Because it seemed to know what's going on. Then it's having trouble implementing a solution. Implementing a solution. It's giving me 2 responses. Why? Use it as feedback. This is a classic and very frustrating behavior in digital signal. The issue persists even after, here's the breakdown of what's happened, filter type, cascaded first order, why the error occurs when changing FPS. Okay, distortion of filter shape, the primary issue. And the harmonic peak becomes dominant. Okay. So the filter is a filtering problem, is it? The filter approximation is breaking down when the sampling rate changes, causing the effect of bypassing window to shift and compute a harmonic or a noise component instead of the true heart rate. Okay, so are we ready to regenerate the complete code with the necessary fix, or not yet? Do we need to consider anything else? Yeah, I'm not sure developing with a human would have been much better, so... But yes, there will be lots of programmers who will disagree on that, but I can see how an experienced programmer would have fallen into the same problem. Yeah, when changing the FPS, the filters gets all messed up. And then we're looking at the second harmonic instead of the main peak in the spectrum to find bits per minute for the heart rate. A definitive fix. Very fast to compute in real time. That's good. Has a flat band pass band, which is ideal for preserving the pulse signal shape without introducing distortion. Okay, we'll see about that. I also want another quick change. There is actually having an option to remove the face from the footage. Is it actually better or worse from what we had? Yeah, we changed the ROI, we changed the quality metric is now more stable. Should be, yeah, it's a bit less jumpy compared to before. I don't think it's much more accurate though. Okay, let's test this, see if it's actually, well, essentially at 60 FPS, we still should be getting 69, 70 BPM. We have still the same problem when changing to 60 FPS. The BPM currently should be 70, not whatever it shows, not 113. So what do you think the problem is? Okay, now we're going in circles. I don't like going in circles, so I might leave it at that. I'm asking to explain first. Still blaming it on the filter. It's not adapting correctly to the change in the sampling rate due to a bug in its mathematical core. Yes, it is open source. Everything I do is open source. All the code is available on BioniChaos.com. I can't even pronounce the name of my own website. But yeah, when you go to the tool, hit F12, sources, and this will be the whole code, because this implementation is JavaScript. Everything ideal is in the same file. So all the functions. I'm not sure if it will work if you, in theory it should work even if you don't have a GPU, but I'm not sure how much memory it will take. In my case it takes 115 megabytes in the browser. Ooh, 727. I don't know, something, I think it's WebGL related. Maybe in this case it's actually releasing it to, maybe the WebGL is not actually working anymore. Well, those are warnings, those are not anyhow, the source code is on the page. For your convenience, we are doing everything for your convenience. We're generating a new version of this, by the way. So from the original one that is deployed, we improved the ROI. ROI is not return on investment, by the way, it's region of interest in this case. And then we also improved that quality metric, so it should not fluctuate as it used to. Just I don't think it's still accurate though, because even if the signal is good, the quality is fair. I was able to get it to good at some stage, but yeah, you need to control the light in the room, things like that. In this version, there's another thing we are trying to fix, and that's being the FPS. So the problem, if you have different FPS on your machine, I'm using 40, I can go up to 60. By the way, if I go up to 60, And let's close this for a sec. If I restart the page with 30, should be using only 100 megabytes in the browser. Maybe if we've increased FPS, it shoots up, I don't know. Oh, what's happening to the gain of my microphone? Super annoying. You know, it should be louder. I don't have to speak as loud. Anyway, and the Gemini, in this case, promised us to fix the code. So essentially we've 60 FPS, we should be still getting our 70 BPM. That's incorrect. It's really annoying. Gemini can't solve this problem. All it needs to do, supposedly, is modify the filters to actually use the current FPS that we're using. This is the correct BPM, 70, 71. Yeah, it's nice and strong BPM. Oh, but when we and we already went going in circles with Gemini. It's not able to solve it. And obviously, every time you will ask it, it will say, yes, you are absolutely correct. It will say you are absolutely correct. And I can fix this for you. We'll explain what the error is. What is that? Yeah, I have to check a few things later before updating the code. Is this correct? I don't know. Yeah, it's the same thing. Anyhow. Yeah, as I said, everything we do is on BioniChaos.com. Go check it out, provide your feedback. We'll try fixing the FPS, or should we just remove that option? But then the question is, what happens if your system is running at a different FPS? Then we will get an incorrect reading. Well, everything is working. This version is working. I need to fix the FPS. Hey, can you explain the problem? We're still having the same problem. Can you explain the problem as a standalone prompt for another developer without any code? We'll try to get another developer to fix this. So put it at the end of the code. yeah, let me know if you have any other questions. Otherwise, check out the website, provide your feedback, and I'll see you next time. Don't forget to subscribe so you get notifications when we are live. You don't miss the live streams. Okay, so it's actually wrote quite an extensive standalone description for a developer. Yeah, we'll give it to another bot, see what it can do. And we'll test it later on.